Okay, we want to find a volume of a parabolic cube. That means that we're looking at a region in the xy plane that's a part of a parabola. Okay, so let R be the region in the first quadrant, bound by the coordinate axes, x and the y-axis, and the curve y equal to 1 minus x squared. So if I were to graph that, 1 minus x squared is going to start at 1 and come down like that. So every y value is determined by 1 minus the x squared, depending on what the x is. Now we're looking at the part bound by the coordinate axes in the first quadrant, so we're just looking at this region here. Okay, it says the solid will have a base that's in R, and the cross section through the solid perpendicular to the base. So if you sliced it from above straight down to the xy plane, parallel to the y-axis, which means slice it along here, they're saying that that cross section of the solid will be a square. So you can see in this picture here what's happening. So coming straight down, you've got this square, and this is for a given x, which is what I have drawn over here. That's a specific x. Now I'm going to get the area of that one square, and I'm going to accumulate the areas of every square, letting x go all the way from 0 over to 1. And so I'm going to have a lot of squares there, an infinite number of squares that I want to add their areas. Now the way you do that is by an integral. An integral will add some value for every x in an interval. So the volume will be the integral of the area of the square. That's for every x, and then the x's will go from 0 to 1. Okay? Okay, so now to get the area of the square, I know that the area is the side squared. So this area will be, if I can find what the length of one of the sides is going to be. Of course, it'll be a formula, so it'll be varied by each x. It's just the side squared. So finding the area of this one square here, I want to find this length. That's going to be the length of the side, and then the area of that square will be side squared. Okay, this length here is the length here. Okay, that length is just the y value on this parabola. That's the distance above the x-axis. So this length is just 1 minus x squared, depending on what that x is. So it'll vary depending on the x value. So for the side here, I'm just going to replace this with 1 minus x squared. That's the length of one side. Square it for the area of that square, and then we're going to accumulate all the areas of the squares from 0 to 1. Okay, so now to integrate that, we're going to need to expand this out. So square it out. We're going to have 1 minus 2x squared plus x to the fourth. Okay, integrate. We're going to have x minus 2x cubed over 3 plus x to the fifth over 5 from 0 to 1. That's going to be 1 minus 2/3 plus 1/5. And then minus 0 when we plug 0 in for all the x's. So now get a common denominator. We better get a positive value since we're talking about a volume. Common denominator is 15, so this is going to be 15 over 15 for 1. 2/3 would be 10 over 15. And 1/5 would be 3 over 15. So it's going to be 8 over 15. Okay, so that's the volume of this solid. So here's the solid. You can see it's kind of an odd shape, but every time you slice it, you're going to have a square. So this is one where you do volume by slicing. So keep in mind you need you're slicing something to get the volume. And so you'll always do it this way. You want to put the area of one single shape, whatever it is, as the integrand to get that volume.